Part 6 of this series is about the Spectrum Analyzer. This tool comprises various analyzers. First, we undock the Spectrum Analyzer window and we minimize the main window. Let's scale the window up, like this. Okay, let us start with the FFT analyzer. FFT stands for Fast Fourier Transform. This is a measuring method that converts a signal into spectral components. These components are single sinusoidal oscillations at distinct frequencies, each with their own amplitude and phase. HawkEye's high-speed FFT generates a high-resolution spectrum of 4096 frequency bands 20 times per second, covering a range from 0 Hz up to the Nyquist frequency, which is always half the sample rate. In our example here we have a sample rate of 88.2 kHz, so the frequency range covered is up to 44.1 kHz. We are using a 7th order Blackman-Harris windowing function. With that, the FFT analyzer achieves an exceptional frequency separation and amplitude precision. Let's click into the FFT window. A white crosshair appears, and the precise amplitude and frequency at the intersection of the crosshair is provided as white readouts here in the upper right corner of the window. To the right you see the frequency resolution, in this case 10.77 Hz at 88.2 kHz sample rate. And below the noise density is shown, which you can use to determine the signal-to-noise ratio of your recording path when you measure in areas of pure noise. We activate hold, which shows maximum frequency levels of the left and right by a petrol-colored area. Two more values are now being shown in the vertical line of the crosshair. The lower one is the falling true peak, and the upper one is the true peak hold value of that specific frequency. With bar engaged, the area beneath the envelope is filled with red bars for the right and yellow bars for the left channel. The linear frequency scale is fixed and it is best being used when the focus is on high frequencies. For example, when checking high resolution content. The logarithmic frequency scale should be used to check low frequency audio content. The frequency axis can be stretched and compressed by mouse dragging, like this. You can also change the scale of the amplitude axis, like this. The next instrument is the spectrogram, that shows a waterfall plot of the FFT. This tool detects periodic distortions in the audio spectrum that become visible as straight horizontal or vertical lines. Like in the FFT window, clicking into the window lets a vertical line appear and a precise frequency readout is given up here. And dragging of the amplitude axis stretches or compresses the dB scale, which has a direct influence on the brightness of the waterfall plot. The linear frequency scale is fixed and the logarithmic frequency scale can again be stretched and compressed. The drop-down menu offers a selection of color schemes: blue, red and yellow, full color or monochromatic grayscale. The grayscale is best being used when laying the spectrogram behind the FFT, like this. Next is the Panorama and Phase window, showing the precise panning of the 4096 frequency bands separately for left and right. The Panorama Face instrument displays the balance that we have in the vector scope in far more detail. Let's open the vector scope and let's switch on the labels. Balance is the upper one of the two bars. Furthermore, there are two correlation stripes that show phase relationship of 4096 individual frequencies by applying a similar color coding as used in the correlation meter. Again, these bars complement the correlation meter of the vector scope. The lower correlation stripe shows the momentary correlation of each frequency, whereas the upper correlation stripe holds the negative correlation value over the time of measurement. Solid red marked frequency ranges below 4 kHz should get a deeper investigation, because they are an indication that energy may be lost due to frequency cancellation. Especially in the base area, this can be crucial. Hold activates two momentary peak hold lines, red and yellow. They indicate the falling peak values. The petrol colored area holds the maximum peak values. And again, there is the linear and logarithmic buttons as discussed previously. The last window is the RealTime Analyzer, showing the frequency spectrum in bars separated by 1/3 of an octave. The bars represent the mono amplitude, while the falling peaks are represented as lines separately for left and right. Activating hold introduces peak hold lines for the left and right channel. When activating left solo or right solo, only the associated channel will be displayed. Mouse dragging of the amplitude axis stretches or compresses the dB scale, and the frequency scale is fixed in this instrument. Right, that's it for part 6. The last video of the HawkEye tour deals with the analysis of high-resolution audio files. See you then, have fun, and bye-bye.